Hi everybody. In this lesson we are going to deal with slopes, also with friction, where we'll combine everything together. So slopes. Let's draw a slope. This is a slope with an angle alpha. And let's suppose there is an object right here. I want to apply forces on this object. So, let's say it's m. Its mass is m. So, downwards, mg. Perpendicular to the surface, the normal force. Suppose now we don't have friction. So what will happen to this object? This object will obviously go down the slope. If I want to do the x and the y axis, I must choose this x and this is the y axis, because the x axis must be with the acceleration which is downwards. So what I need to do now, if you remember our first lesson, I need to break this vector into its components in order to calculate what the Newton laws. So, how do I know how to break it into components? Always the angle between the y axis and the mg is the angle of the slope. Why is that? I will show you in another drawing. Let's suppose this is the same slope, but instead of drawing the object as a square, I draw it as a point. This is the mg. This is the normal with the y on the y-axis. This is alpha. This is 90. This is 90 minus alpha. And this angle must be alpha because these two must be 90 degrees. So when you need to find angles and you're not sure because the drawing is large, you have boxes, draw a little drawing by the side and instead of the box, apply a dot, a point. Because we treat this box as a point, we just illustrate it with a box because just to make it more, more real. But in order to calculate the angles, just draw a dot and then you can calculate it easily. So we say the angle between the y-axis and the mg is always the angle of the slope. Now, when I know it, it's easy to break it into its components. We will break it to this one and that one. Who will get the cosine? The one next, the vector next to the angle, this one. So this will be mg cosine alpha, and this will be mg sine alpha, and I wipe it off because I have these two instead of it. Now I can apply Newton laws on it. We know that when an object goes down the slope, it doesn't go up nor down. It doesn't go in the slope, it doesn't go up the air. So according to the first law of Newton, the normal force must be equal to mg cosine alpha. And in the x direction, we have this force, nothing there, so obviously this object will accelerate down the slope. So if I want to find the acceleration, according to the second law, mg sine alpha minus nothing, because there's nothing there, equals to mass multiplied by the acceleration. And if we divide this equation by m, we'll get the acceleration. A equals to g sine alpha. So two things I can say about this object. It will accelerate downwards with this value, this acceleration, and the normal force will not be mg like we always used to know. You remember when an object was on a flat surface, the normal was always equals to mg. But here the normal equal to mg multiplied by cosine alpha. Cosine alpha is a number between 0 to 1, so the normal force is less than mg, which means it presses less on the slope, and the slope, according to the third law of Newton, press back less than mg on the mass. Okay, so this is the idea. So all the difference between these problems and the former problems we dealt with, that we must break the mg into its components, and the angle between the y-axis and the mg is always the angle of the slope. So let's do some exercises with, without friction, with friction. Okay, so let's start. First example. Let's say I have this slope. Let's say m equals 10 kilograms, pulley, mass, m equals 5 kilograms. And the angle, I forgot my calculator, so I'll put an angle that we can calculate without the calculator. I'll put 36.87. And I remember that cosine 36.87 equals to 0.8 and sine 36.87 equals to 0.6. I will use it later because, again, I forgot my calculator. So, the question is this: will this system accelerate? If so, I want the acceleration and I want the tension of the string. So, let's do it. First of all, we apply forces. Downwards, 50 newtons. Upwards, tension. No normal because no surface. Downwards, always downwards, the mg. So it's 100 newton. T, outside. And the normal force perpendicular to the surface, like that. Normal force. Okay, now I know this is the line of direction that it's going to move up or down. This one is going to move also up the slope or down the slope. So I must choose for this object this x and y axis. So I must break this 100 Newton into its components. Remember, the angle between the mg and the y-axis is always the angle of the slope. So this one will be also 36.87. Now when I break it into this one and that one. Who will get the cosine? This one. This is 100 cosine 36.87 and this is 100 sine 36.87. And now I can calculate them because I know the value of cosine and sine 36.87. Sine 36.87 is 0.6, multiplied by 100 is 60. This is cosine 36 that I'm gonna, which is 0.8, multiplied by 100, which is 80. Okay. Now I ask myself a question. This way, we have 60 newtons, which pulls the system that direction. That direction, I have external force, the 50. Who is bigger? 60. So if 60 is bigger than 50, 60 is bigger than 50, this is why the system, this all to mass, will go that way. And now that I know it, I can write Newton laws. Let's start with this one. This one I know goes up. So T minus 50 equals to m, which is 5, multiplied by the acceleration a. This one goes down the slope. So 60 minus t equals to the mass multiplied by the acceleration. If I want to know what's the normal force, I'll write it on the side here. The normal force, because it must be equal to 80 newtons. Why? Because this mass, it goes this direction. It doesn't go on that direction. So in this direction, according to the first law of Newton, these forces must be equal to those forces. So the normal force must be equal to the 80 newtons. Okay, let's add this equation up. I'll get 60 minus 50 equals to 15a. So 10 equals to 15a. A equals to 10 over 15, which is 2/3. I have the acceleration, that's direction, and if I want the tension, I just insert 2/3 here, move the 50 there, and I have the tension. So this is our first example, how to deal with a system on slope. One more. Second example. Okay. Okay, this mass is, I'll use 10 because it will be easier for me to deal with these angles. This will be 36.87 again. This will be 20, but I also have external force F here. And I'll ask two questions later. First of all, let's just M1, M2. Let's draw forces and then we'll ask the questions. So downwards, 200 newtons. Upwards, T. Downwards, mg, which is 100 newtons. This way, perpendicular to the surface, the normal force, and this one is external F. The first question I want to know what must be F minimum in order for this system to go that way. F minimum so that the system will accelerate that way. Obviously, if it will be 1 million newtons, it will go that way. But I want the minimum force that makes the system go this way. So first of all, let's draw the x and the y. I must break the 100 into its components. This is also the 36.87 because the angle between the mg and the y, always the angle of the slope. So when I break it into its components, I have here the 100 cosine because it's next to the angle. 100 cosine is 100 multiplied by 0.8, it's 80. And 100 sine, it's 100 multiplied by 0.6 is 60. And I wipe it off, 60 newtons. Now let's answer this question. In order for this system to go that way, I need that these forces will be bigger than these forces. Here I have F plus 60. Here I have 200. So this one must be bigger than that one. And if I want the minimum, I'll just I'll just compare them, and the F I will get, which is 140 newton, is the F minimum that I need in order to this system to start. It won't move with 140, it will be exactly in equilibrium state. But if I one more this way, it will start moving that way. So we say this is the F minimum. We don't say 140.0001, we just say 140. So the second question is, what happens if F equals to 100 newtons? What's the acceleration? Now that I know that F minimum in order to go this way is 140 and the F is 100, obviously this system will go that way. So if we know that it will accelerate this way, that way, let's find the acceleration according to the second law of Newton. Let's start with this one. It goes downwards. So 200 minus T equals to the mass multiplied by A. And let's go to this one. T minus F, which is 100, minus 60, which is 160, equals to the mass, which is 10 multiplied by A. If I want to say something about the normal, again, the normal will be equal to 80 newtons. But here it doesn't matter. Okay, so if I add them up, I'll get 200 minus 160 equals to 30A, 40 equals to 30A, A equals to 1 1/3 meters per second squared, of course. So, how do I know that this equation is okay? 200 is this force, 160 is this force, 200 minus 160 equals to the mass of the system, which is 30 multiplied by A. This equation is, I could have gotten it if I were to look at the system as a whole, as one. But solve it like this. It's better. Okay, let's add friction into our problems. Wow, why didn't I wipe it off? Okay, I'll write it again. Okay. Let's use another common angle. Cosine 53.13 is 0.6 and sine 53.13 is 0.8. Let's use these angles for the next questions. So we want to deal with slopes. I have a slope, this one, and I have an object here on the slope. Its mass is, I'll use the 10 kilograms, I like it, 10. And the angle is 53.13 degrees. But I have also friction. Mu static is 0.5, mu kinetic is 0.1. Okay, I want to know if this object, it's in rest mode now, I want to know if it's going to accelerate downwards or it's going to stay like that. Okay, so I remind you how we deal with these problems. First of all, we apply forces without friction. So we have 100 newtons, the normal force, and that's it. Now, I know that this is the x pole and this is the y pole. This angle is the angle between the y and the mg, is always the angle of the slope. Let's break it into its component. It's 100, it will break into that one and that one. This one will get the cosine. This one will be 100 cosine 53.13, and cosine 53.13 is 0.6, so 0.6 multiplied by 100 is 60 newtons. This will get the sine. 100 sine, which means for 53 is 0.8, so 0.8 multiplied by 100 is 80 newtons. Okay. Now I remind you what we do. We apply the friction force. The friction force is always against the tendency of the mass to move. This mass obviously wants to go down the slope, so the friction will be this direction. Let's find F static max and F kinetic. F static max is mu static multiplied by the normal force, which in this case is 0.5 multiplied. Normal force is 60, so it's 30 newtons. Mu kinetic multiplied by the normal force equals to 0.1 multiplied by 60, which is 6 newtons. Now we ask ourselves the question, is the 80 newtons, which pulls this mass downwards, bigger than the F static maximum? Yes, it does. 80 is bigger than 30. So what will happen to this mass? It will go down the slope, it will move down, move, accelerate, and in order to calculate the acceleration, we will use the kinetic friction force, because If it moves, it means that the friction is kinetic, it's not static anymore. So what we get according to the second law of Newton is 80 minus F kinetic equals to 10 multiplied by A. 80 minus 6 equals to 10 multiplied by A. 74 equals to 10A. A equals to 7.4. So this mass will accelerate downwards with this acceleration. What really happens is, I remind you again about the friction. It's in rest at the beginning. The 80 Newton, what does it do? It lifts this mass up the bumps. There's a bumps. Remember that when I showed you in the previous lesson that this mass is like that. It's sunk in its bumps. And the 80 Newton managed to lift it from the bumps, and once it's up these bumps, it slides with a friction of 6. And it accelerates according to the second law of Newton. Okay. One more. Okay, let's change the direction of the slope. Okay, let's say this is the slope. Not enough room. So, again, this is the slope. This is alpha, which is 53.13. And I have external force here, F. This mass is 10 kilograms. This mass is also 10 kilograms. This F, I don't know yet. I'll ask question about it. And there is friction. Mu static is 0.5. Mu kinetic is 0.1. Okay. Let's apply forces and ask questions. First of all, we apply forces, I remind you, without the friction. So, we have 100 newtons here, normal force here, tension there, tension here, external force, I have it, and also I have the 100 newtons here. No, let's apply the F, I want to apply it here. I want to put the external force here. Instead of this, I put it here. Okay? I didn't put the friction force yet. Now I'm going to break the mg into its components. Again, the angle between the mg and the y-axis is the angle of the slope. This is the alpha. So this, when I break it into its components, this will get the cosine, this will get the sine. 100 cosine alpha is 100 multiplied by 0.6 is 60 newtons. And 100 multiplied by sine alpha is 100 multiplied by 0.8 is 80 newtons. Okay, these are the forces without the friction. Why can't I put friction? Because I don't know the tendency of this system to move. If there is no F at all, 100 is bigger than 80, so obviously it will want to go this way, the friction will be that way. But maybe F is bigger than 20, so all of these forces are bigger than 100 and the tendency is to move that way. I don't know. So I must ask a question. So the question is F minimum, so that the system will start accelerating that way. Acceleration this way. What is the minimum F I need in order for this system to accelerate that way? So first of all, I remind you, we find the F static max and the F kinetic. F static max is mu static multiplied by n. Mu static is 0.5. Multiply n equals to 60, which is 30 newtons. Mu kinetic is mu kinetic multiplied by n is 0.1 multiplied by 60, it's 6 newtons. Now let's ask the question. What F do I need here, the minimum F I need in order for this system to go downwards? So first of all, if it wants to go downwards, obviously the friction will be this way. Now I'm going to ask myself, the forces in this direction is F plus 80. I want it to be bigger than the maximum force, external forces in this direction. I already have 100, and I will put here the friction, the maximum friction that can be, which is 30. I want these forces to be bigger. If I want the, just foo, and it will move, I will just draw an equal sign, and I will get the minimum force I need in order for this system to go that way. This way. So F will be 130 minus 80 is 50 newtons. F minimum. And again, the F minimum means that if I apply 50 newtons, it will be on the foo, and it will move. Okay? So we say F minimum. Now I can ask another question. What happens if F is less than that or more than that? Let's say if it's more than that. What happens? I need another place here. What happens if F now is 70 newtons? What will be the acceleration? This is the second question I want to ask. Now, if F is bigger than 50, obviously it will accelerate that way because it's bigger than the F minimum I need. So if I know that it will accelerate this way, I can apply the second law of Newton. Let's do it. In this direction I will have F plus 80, which is 70 plus 80, F is 70, minus all the forces in this direction, F kinetic, because now it's moving, so F is kinetic, minus T equals to the M, which is 10 multiplied by A. And this one will go up, so T minus 100 will be equal to the mass, which is 10 multiplied by A. If I add them up, I will get 150 minus 100 minus the F kinetic, which is 6, equals to 20A. And again, this equation deals with the system as a whole, because 150 is the forces this direction. 106 is the forces on this direction. So 150 minus 106 equals to the mass of the system, which is 20 multiplied by A. So it's, I don't have my calculator, I told you that before. This is 50, 50 minus 6 is 44, I think, equals to 20A. A equals to 44 divided by 20, whatever, 2.2. I hope it's right, 50 minus 6. I think it's okay. Okay, let's ask another question. What happens if F equals to 0? What will happen? Now, if F equals to 0, it's another story. Why? Because if F equals to 0, this doesn't exist. I have 100 here, 80 here. It means that the system will want to move that way. So the friction will not be here anymore, it will be here. And I must ask the question if the 100 can overcome the maximum friction and all the forces in this direction. Let's see. I have 100 in this side, which pulls the system. Which are the largest forces that can be in this direction? 80 is obviously because it's there. And the maximum friction that can be is 30. Now 100 is less than 80 plus 30. So this system won't move. No move. It will not move. And if it will not move, what can I ask? I can ask you what the friction will be. I'll show you two ways to calculate it. First of all, if I look at this system as a whole, I say, according to the first law of Newton, if the system doesn't move, all the forces, external forces here, must be equal to the external forces there. So 100 must be equal to 80 plus F static, but not static max, because. So F static will be 20 newtons. It can reach up to 30 newtons, but in this case it will adjust to 20 and the system won't move. Second way to show it, if I know that it doesn't move, I can apply the first law of Newton to each mass separately. This one I can write T equals to 100 because it doesn't move. And this mass I can write T equals to 80 plus F. F static, obviously, because it doesn't move. And if I, if I just compare them, I'll get F static equals to 20. So two ways to show it. So what does it mean about the system? If F is less, it can be less than 0. So if F is 0, the system won't move. If it's more than 0, obviously it won't move until its minimum is 50. From 0 to 50 it won't move. From 50 it will start to move. One other thing, very important thing, from 0 to 20 it will not move, but the tendency to move will be this way. From 20 to 50 it won't move either, but the tendency to move will be that way because these forces will be bigger than that one. And above 50 it will move that way, it will accelerate. Okay, so again, from 0 to 20, which means all the forces here will be from 80 to 100. The tendency will be this way, but it won't move. From 20 to 50, the tendency will be that way, but it will still not move because I can't overcome the friction. And above 50, it will move that way. Okay, more. Okay, now let's do a question just with letters in order to see something very, very important. A very, very easy experiment you can do at home. I'll show you. Suppose I have a slope. This is the slope, okay? And I have a mass on the slope. This is the mass. Now look what I do. It will cost me my telephone. Okay. Look. Oh, from this angle, the telephone started to slide down. Up until this angle, it didn't move. Now it started moving. So there is an angle, a minimum angle, that I need in order to this telephone to move. Why? Because up to this angle, what happens? The friction can adjust to the pulling force downwards. But from a certain angle, which is here somewhere, the pulling force overcomes the biggest friction that can be, and it slides with kinetic force. I'll put it back. Okay, let's analyze it. So, I have a slope with alpha. Let's say I have mu static and mu kinetic. And I have a mass here. Let's apply forces on the mass. mg, normal force, without the friction. Now, I break this mg into its component. The angle between the y and the mg is the angle of the slope, alpha. So when I break it, I will get mg cosine alpha and mg sine alpha, and I wipe it off. Obviously, it will want to go downwards, so the friction will be up the slope. Now, let's find the F static max and the F kinetic. F static max is mu static multiplied by the normal force, which is mu static multiplied by normal force is equal to mg cosine alpha. F kinetic is mu kinetic multiplied by the normal force, which is mu kinetic multiplied by mg cosine alpha. Okay, now what is the condition for this mass to start sliding? The condition is that this force must be bigger than the biggest friction force there is. And the biggest maximum friction force is this one. So the condition, in order for this mass to move, I'll write that mg sine alpha must be bigger. If I want it just, if I want the minimum, I'll just put equal. If I want bigger, I'll write bigger. It doesn't matter. Let's write bigger. If mg sine alpha is bigger than the F static max, this mass will start to move. Let's calculate it. Mg sine alpha is bigger than mu static mg cosine alpha. If I divide it by mg, it goes. If I divide it by cosine alpha, I'll get mu static is smaller than sinus sine alpha divided by cosine alpha. Sine divided, let's write it, sine alpha divided by cosine alpha. This sine over cosine is known also as tangent alpha. So this is the condition in order for this mass to move downwards. The tangent alpha must be bigger than the mu static. And in the extreme case, we write tangent alpha equals to mu static. When it's equal, a little more angle and it goes down. So if I want just the minimum alpha I need, I write this one. Every alpha above this alpha will make the object go down. So this is a very important condition in order to find which angle I need in order for this mass to stay rest or to go down. This is how I get the minimum alpha I need for this mass to go down. Okay, let's do another problem now. Yes, let's do another problem. I'm wiping it. Okay, let's do this one. Okay, this is alpha equals to 53.13. This is m equals to 40 kilograms, m equals to 10 kilograms, mu static equals to 0.5 here and here. I have two frictions, here and here. And mu kinetic equals to 0.1. And I want to know if this system is going to move, and if so, what's the acceleration? As first question is acceleration. Again, let's do it. Let's apply forces without the friction. So I have 100 newtons here, normal, let's put N1 because I will have N2, T, N2, 400 newtons. Let's break it into its components. This is the slope. This will be alpha because the angle between the y-axis and the mg is the angle of the slope. This is 100 cosine alpha. 100 cosine 53 is 0.6 multiplied by 100 is 60 newtons. And this will be 100 sine alpha, which is 100 multiplied by 0.8, it's 80 newtons. I'm wiping it off. Now I ask myself, this system wants to go obviously downwards. Why? Because 80 is pulling it down, nothing is pulling it this way, so the friction will be here, let's put F1, and here let's put F2. In order for this system to go downwards, I need that 80 to overcome the biggest friction forces, these two friction forces. Let's find them. F1 static max is mu static, which is 0.5, multiplied by the normal one, which is 60, which is 30 newtons. Okay, F2 static max equals to 0.5 multiplied by N2. N2 is 400, which is 200. Okay, so what can I say about the 80? 80 can overcome these two. 80 can overcome 230 newtons? Obviously not, it's smaller than them. So what will happen? The system won't move, and both of them will be, the sum of them must be equal to 80. It doesn't really matter how they divide themselves, but the sum of them must be 80 according to the first law of Newton, because 80 must be equal to 80 on that side. So now I'll ask another question. I'm putting, so first question is A equals to 0, won't move. Second question, I'm applying, let's say here, F external. And the question here is, what's the F minimum in order for this system to move, to accelerate that way? Okay, so again, if I want to move the system to accelerate that way, first of all, obviously it must be bigger than 80, because otherwise we want it, tendency will be this way. But if I want it to move this way, first of all, I need to understand that the forces, the friction forces, will be at the opposite direction. Because if the tendency is to move that way, the friction will be that way. Now, what I want to do, I want to ask the F minimum to overcome the biggest forces that can be on the other direction. It must overcome the 30, the 80, and the 200. So if I want the minimum force, I will ask it to be exactly 80 plus 200 plus 30, which is 310 newtons. So if F minimum is 310, one more pips and it will move that way. If it's less, it won't move. And if it's 0, as we showed before, the system will want to move that way, but it won't move because 80 can't overcome the frictions. So now let's add another question. So the answer is F minimum is 310 newtons in order for the system to want to start to foo, and it moves this way. So third question, what happens if F equals to 400 newtons? What's the acceleration? So now we know that if F is bigger than the F minimum I need in order for this system to go that way, it will obviously move. And if it moves, the frictions will be kinetic. Let's find them. F1 kinetic is 0.1 multiplied by the normal, which is 60. So it's 6 newtons. And F2 kinetic is 0.1 multiplied by 400, which is 40 newtons. So now, let's write the equations. This mass, I will write F, which is 400, minus T, minus F2 kinetic, which is 40, must be equals to 40 multiplied by A. All the forces, I'm talking about this object, in this direction, minus all the forces on that direction, must be equal to the mass multiplied by the acceleration. And this one, all the forces in the moving direction, which is T, minus all the forces in this direction, which is 80, and minus the kinetic force, which is 6, must be equal to the mass, which is 10, multiplied by A. Let's add them up. 400 minus 40 minus 80 minus 6 equals to 50A. What can I say about this equation? If I were to look at this system as a whole, I would write 400, which pulls the system, because F is 400, minus all the external forces, which are F2 means 40, 6, and 80. 400 minus 40, 6 and 80 equals to the mass of the system, which is 50, multiplied by the acceleration. No calculation. Okay, A equals to something. It doesn't really matter. Okay, so let's conclude this system. We saw that if F is nothing, it won't move, but the tendency is to move this way. What happens if F is bigger than nothing? It's bigger than 0. Up to 80, it will want to move that way, but it won't move. From 80, if it's exactly 80, it hasn't any tendency to move, so there will be no frictions at all, but it won't move. If it's above 80, the tendency will be to move this way, but it won't move until 310. And from 310, it will start moving. Let's sum it up. When F is between 0 to 80, it won't move, but the tendency to move will be that way. So no move, but tendency will be this way. When F is 80, also no movement, no moving, but there will be no tendency. There will be no frictions. Again, why? Because if this force is exactly the same as that one, there is no tendency to move. And what did we say about friction? Friction is always against the tendency. If there is no tendency, there will be no friction. What happens if F is between 80 and 400? If F is between these two, obviously Newton, again, there will be no movements, but the tendency will be that way. And when F is bigger than 400, it will accelerate, it will move. Which way? That way. And the forces will be, the friction forces will be kinetic. Okay, this is the sum of what's going to happen to this system. Okay, let's wipe it out. Okay.